Lab number 3, Osmosis/Diffusion Challenge.
Purpose: investigating the water potential of a potato by measuring the mass change and determining the molarity of the solutions and molar concentration of the potato discs.
Materials that were used. The pre-prepared cylindrical potato was sliced with a knife into 6 small cylindrical pieces. Approximate dimensions are 3 cm in radius and 1 cm in height. The mass of the potato slices were masked and recorded. All of the potato slices were placed into labeled cups. 30 milliliters of a sucrose solution of a selected color was measured and poured into the cup. The time and color of the solution was recorded. Repeat steps 3 to 4 for each of the 5 other sucrose solutions. The potato and the solutions were observed. The observations were recorded. The trays were masked and recorded. After 15 minutes, the potato slices were removed from their respective plastic cups and placed into a tray, each using tweezers. The potatoes on their trays were masked on an electronic scale. Remove the potato slices in the same order they were put in. Observations: dropped potato slices. Potato and orange and blue solutions sank to the bottom of the plastic cups, whereas all other potatoes floated. Potato and blue solution looked like it was falling apart. Table 1.1 shows the potato mass change in percentage. Final mass is the potato and the tray mass, which is subtracted by the tray mass to obtain the actual mass. The mass difference is then taken by dividing the initial mass, outputting the percentage change in mass. Table 1.2 is the solute potential for the potatoes. The only variable in this set of calculations that was changed was the molar concentration, C. If a potato core is allowed to dehydrate by sitting in the open air, the water potential would decrease. Potato core loses water. The concentration of solute increases because the ratio of solute to water increases. Solute concentration and solute potential. When solute concentration increases, solute potential decreases because this prevents water from moving. They act as obstacles. When solute potential decreases, water potential decreases because it lessens the tendency of water to move. If a plant cell has a lower water potential than its surrounding environment, and if pressure is equal to 0, the cell will gain water because the environment has a higher water potential than that of the cell, so the water will tend to move from the environment, higher water potential, into the cell, lower water potential. Therefore, the cell is hypertonic and the environment is hypotonic. In a hypotonic solution, cell will experience a net gain of water, and in a hypertonic solution, cell will experience a net loss of water. If water potential for a sucrose solution in a dialysis bag is negative 6.25 bars and is immersed in a cup of solution having a water potential of negative 3.25 bars and a water potential inside and outside the bag is 0, the bag will gain mass because the solution has lower water potential than outside. Negative 6.25 is smaller than negative 3.25. Since outside has a higher water potential, water will flow inside the bag and will gain mass.
Chart 1.3. The x-intercept of the line of best fit is the molar concentration of the potato. This line was created by assuming that the solution where the potato gained the most mass had a molarity of 0, and that which lost the most mass had a molarity of 1. According to the chart, the molarity of the potato was about 0.65. Here are the calculations of the molarity of sucrose based on the data. Here is the graph of molar concentration and percent difference in mass of the potatoes given the concentration of sucrose in each solution. According to this graph, the molar concentration of the potato is 0.225. The data did not match what was supposed to happen. Potatoes were dropped, resulting in accumulation of particles on the sticky sucrose-covered potato, which altered the masses. The electronic scale was wet, which caused inaccuracy in mass measurements. According to the data, the higher the concentration of sucrose, the greater the potato percent mass change. What's supposed to happen? The higher the concentration of sucrose, the lower the potato percent mass change. The data that resulted can be explained by how sucrose is sticky. The percent mass change of the potato increased as the concentration of the solution increased because sucrose particles stuck to the potato. The assumption made was that all mass change was due to diffusion of water, but did not account for the movement of sucrose particles. The lower the concentration of sucrose in the solution, the less sucrose particles stuck to the potato. Since the mass of each potato was only around 2 grams, this difference in mass due to sucrose particles made a big difference, since the total mass was so low. Applications of this lab include culinary arts, applying it to improve the taste of food by studying the molarity of different fruits and veggies like potatoes to seasonings like salt and sugar. Also, we can use this knowledge to experiment with nutrient intake through the moisture in the air for plants. Conclusion: the molar concentration of the potato discs were 0.225.
Created using Powtoon.